Today, the topic for discussion is forced vibration. So, what is forced vibration? Is a vibration of a body under the influence of an external force. Under the influence of an external force. In case of forced vibration, the force applied has some frequency, exciting frequency. So that creates vibration in the body. The frequency of vibration also, that frequency at which the body is oscillating, both will be same. Both will be same. Frequency of external force and the body vibrates, the frequency of the body vibration, both will be same. So, for forced vibration, examples are air compressors, IC engines, machine tools, and so on. So, based on the forcing function, it is classified into three. One is periodic forcing function, impulse forcing function, and random forcing function. So, we are going to discuss about a periodic forcing function. Periodic forcing function. This is what. So, this is predictable. It is deterministic. So, in this topic, we are going to discuss about periodic forcing function. What is meant by impulse forcing function? See, impulse forcing function. This is non-periodic. Non-periodic. It produces transient vibration. Transient vibration. They will die out over a period of time. So this is due to rock explosion, punching. So these are all will produce impulsive force. Because of that, vibration is created. That is transient vibration. It will die out over a period of time. Hence, it is not important. Next one is a random forcing function. Random forcing function. This is unpredictable. This is unpredictable, non-deterministic. Non-deterministic. So hence, it produces random vibration. It produces random vibration. This is due to ground motion during earthquake. Ground motion during earthquake and the vibration produced by wind. These are all coming under this category. So this is unpredictable, non-deterministic. So this is random vibration. But we are going to discuss about the periodic vibration. Again, the first vibration is classified into damped vibration and damped vibration. Damped vibration means the system has damping property. In case of undamped vibration, damping is zero. Damping is zero. The value of C, damping coefficient is zero. That's what you can understand from the undamped vibration. So now, you take a system. You take a vibrating system. It has a spring. It has a damper. The spring value is K. This is C. And it has a mass. When it is subjected to a periodic force. When it is subjected to a periodic force, how the vibration will be. That's what we are going to discuss today. Now you take the stiffness is equal to K. Stiffness is equal to K. And the damping coefficient is equal to C. The mass of the body is equal to M. And it is subjected to a forcing function. The body is subjected to a forcing function. It can be defined like this. F naught into sine omega t. F naught into sine omega t. F naught is a force in Newton. T is time. What is omega? Omega is equal to circular frequency of the forcing function. That is exciting force. The frequency of exciting force. Circular frequency of the exciting force. So this is a way. This is about the applied force. This is applied force. So due to that, this body will be vibrating. Body will be vibrating. So now we can write equilibrium equation. So here there will be three forces. Four forces. Three forces. One is since the body is subject to acceleration, it will have inertia force. That is m into d square x by dt square. The body will at particular position. So here, due to spring will be applying a restoring force. That is k into x. K is a stiffness, displacement is x. Again, this damper will give resistance to this vibration, that is C into dx by dt. Addition to that, we have the forcing function. This is a forcing function. This is applied on the mass. So now the equation is m into d square x by dt square. This is inertia force plus damping force, that is C into dx by dt. C is force per unit velocity. So we are multiplying with the velocity plus k into x. That is equal to F naught forcing function. F naught into sine omega t. So this is a equation. In the previous case, here we do not have the forcing function. Since it was free vibration, we do not have the forcing function. It was 0. So we know that solution for that. So here, when the differential equation is in this form, the solution will have two equations. The solution will have two. One is xc, complementary function. Another one is particular integral. We know how to calculate xc. Already we have discussed what is xc. Xc is equal to let us take, actually we have to take x. Here we will take x1. x1 into e power minus psi omega nt sine omega d t plus phi. Phi, let us take phi 1. Here phi 1. Another phi also we are going to consider. So let us take this is phi 1. So this is xc. What about xb? xb, the value will be, you have to calculate. We have to calculate. So if we calculate, the xb value will be, let us take this is f naught by k into sine omega t minus phi. So this phi is different from this phi, divided by root of one minus omega by omega n the whole square plus 2 into psi into omega by omega n the whole square. So this is a equation. So this is complementary function. This is particular integral. This is what we got the solution. Here f naught is equal to forcing function, this value, the force value, sine omega t. What is omega? We have this omega here. This is natural frequency of the exciting force, that is forcing function. And phi is a phase angle difference. We will discuss about phase angle. And omega, this is frequency of forcing function. Omega n is equal to natural frequency. Here psi is equal to damping factor, and omega is equal to frequency of natural circular frequency of forcing function. This is natural frequency, that is. So this is the equation we get. So in this equation, this will die out over a period of time. As time increases, this will die out. So we are not going to give importance to this. So we are going to take only this. So here also, this is to give curve form. So if you want to calculate, the magnitude. So here, if you draw this one in terms of curve, it will be like this. Here, we are interested in this value, the amplitude value. So this sine portion will give the curve. If you remove this, it will give this value. This will give this value. So I am interested in finding the amplitude of vibration. Amplitude of vibration, that is equal to x is equal to f naught by k. F naught by k divided by root of 1 minus omega by omega n the whole square plus 2 into psi into omega by omega n the whole square. So this is the equation. So this equation will give amplitude of vibration in case of forced vibration. Forced vibration. Here there are two terms. However, this is layout over a period of time. We are not taking this one. So here another term is phase angle, phi. Phase angle. What is phase angle? Phase angle means here we have there are two forcing functions. So here we have two frequencies. One is we apply a force, it will have a frequency. It will have a frequency, it will have a cycle. So if you draw that one, it will be like this. It will be, so this is the forcing function. This is the forcing function. Here what is F naught? This is F naught. This is F naught. Actually, the forcing function is F naught sine omega t. F naught sine omega t. If you draw this one in terms of in graph, it will be like this. Here, this is F naught. The amplitude is F naught. This is the what is the frequency? Omega. Frequency of this is omega. So now we are going to draw another cycle. Another cycle. This is, what is this? This will be, this represents the amplitude of vibration. So during the, while the force is applied, it will be vibrating. It will be vibrating. That vibration is drawn. Vibration is drawn. Here what is this? This is x. This is x. When you compare these two, this frequency and this frequency, both will be vibrating in the same frequency. So here this is the omega is the frequency of the forcing function. So if you apply a force like this, then this body will be the body also will be vibrating in same omega. Same omega only it will be vibrating. However, its natural frequency is different. It will be vibrating in omega only. But this is starting at this point. It is starting at some delay. So this is known as phi. This is known as phi, phase angle difference. So that is, what is phi? Is a phase angle difference between the forcing function and displacement. What is displacement? Displacement of this body. Displacement of this body. Forcing function is applied to this body, and this body is displacing. But however, the displacement frequency and the forcing function frequency are same, but there will be a time delay. There will be a time delay. That is known as phi. That is known as phi. So to calculate phi, the equation is tan phi is equal to 2 into psi into omega by omega n divided by 1 minus omega by omega n the whole square. So this is the tan phi value. What is tan phi value? It is a phase angle difference between the forcing function and displacement function. Displacement function. And what is F naught by K? What is F naught by K? If body is like this, actually the function is a force is a function. Force is a function of time. But if you take only force, magnitude only if you take, means what is the meaning? That meaning is that it is when a static force of F naught is applied. When a static force of F naught is applied, what will be the displacement? That will be, I am taking XST, static deflection. When this body is subjected to static force instead of forcing function, if static force is applied, the displacement will be XST, static deflection. So you can take this is XST, static deflection. Then the X, this is the amplitude of vibration divided by, if it is applied only static force, the displacement is XST. So X amplitude of vibration divided by static deflection is equal to 1 by 1 by 1 minus omega by omega n the whole square plus 2 into psi into omega by omega n the whole square and root. So this will be the equation. Almost these two are same equation. Here our objective is to find the amplitude of vibration. Here to find the ratio between the amplitude of vibration and static deflection. So this is known as magnification factor. This is known as magnification factor. So now we have three equations. One is amplitude of vibration, another one is magnification factor, and third one is tan phi. That is the phase angle difference between forcing function and vibration, displacement function. So now we will solve one problem. So these are the equations. See, I told in this forced vibration, there will be two x value, that is the complementary function plus xp. If you draw graph for this, it will be like this. If you draw in the form of cycle, it will be like this. If you draw for this, it will be like this. It will be like this. Actually, in case of forced vibration, both are happening together. So if you combine these two, you will get a graph like this. You will get a graph like this, but this will die out over a period of time. As time increases, it will die out, but this will continue. This will continue. So that's what, for calculation purpose, we are not taking this, since it will die out over a period of time. But if you combine these two, the graph will be like this. Graph will be like this. After that, this graph will be continuing. This graph will be continuing. There will not be any disturbance in the vibration. So here you see, because of the transient vibration, here some disturbance. This will die out over a period of time. After that, it will give a vibration like this. So here, what is the frequency of this? Frequency will be omega. This omega and forcing function frequency both will be same in case of forced vibration. Now, when you draw the magnification factor in graph, it will be like this. So this is the equation for magnification factor. In the x-axis, we take omega by omega n. You take this. In the z-axis, you take the magnification factor, and different value of psi. When psi is equal to 0, psi is equal to 0.125, psi is equal to 0.25, psi is equal to 0.5. Then 1 means it is a critical damping. Tau psi is equal to 2 means it is over damping, that we do not require. So here see, when omega by omega n is equal to, the magnification factor is varying as a function of omega by omega n. As omega by n is less than that, see, the amplitude will be like this. Magnification value will be like this. So at omega by omega n is equal to 1, it is maximum. See, the magnification factor is maximum. What is the magnification factor? That is x by xt. This is static deflection. This is amplitude of vibration. So what you can understand is, at natural frequency, that is omega by omega n is equal to 1 means that is natural frequency. Resonance, at the resonance, the amplitude of vibration, the magnification factor is more. That is amplitude of vibration also more. That's what we can understand. As omega by omega n value increases, after 2, the magnification factor and the amplitude of vibration decreases drastically. So when frequency is less than 1 also, at this region it is less. So at particular region, in this region, the amplitude of vibration, that is magnification factor, is very high. That is one point. Another point is, as psi value increases, at low psi value, Amplitude of vibration is more. Magnification factor is more. But psi value increases, magnification factor is decreasing. So there are two things you can understand. One is as psi value increases, uh, x value and magnification factor are decreasing. Is inversely proportional to damping factor. Another thing is at resonance, the amplitude of vibration and magnification factor are very high. So below and after that, it is decreasing. That's what you can understand from this graph. This is the angle for phase angle. This is in the y-axis phase angle is taken. In the x-axis omega by omega n is taken. Omega by omega n is taken. For different value of psi, the graphs are drawn. You see, when the omega by omega n value is less than 1, here you see phase angle is less than 90. Is less than 90. Exactly at resonance. Exactly at resonance. That is omega by omega n is equal to 1. The phase angle is exactly 90 degree. Exactly 90 degree. So after 1, it is more than 90. It is more than 90. That is what you can understand from this graph. So this is phase angle. What is phase angle? Is a phase angle is a phase um, phase angle is the angle between the forcing function and displacement function. There is a time delay. There is a lag. There is a lag. So one will start like this. Another will start. This is the forcing function. Another will start slightly later. Slightly later. It will go like this. So this is phase angle difference. Phase angle difference. The phase angle difference is less than 90 degree when omega by omega n is less than 1. When omega by omega n is greater than 1, the phase angle is more than 90 degree. And exactly at 1, omega by omega n is equal to 1. That is at resonance. Phase angle is equal to 90 degree. That's what we can understand. Now, let us solve one problem. See, in this problem, a vibrating system, a forced vibrating system, the mass is given 10 kg. Mass is given 10 kg. M is equal to 10 kg. The stiffness of the spring is, that is K. Stiffness of the spring is 10 Newton per millimeter. You convert this into Newton per meter. So 10,000. 10,000 Newton per meter. The viscous damping causes the amplitude to decrease to 1/10 of the initial value. 1/10 of the initial value in 4 complete oscillations. 4 complete oscillations. Now it is oscillating like this. It is vibrating like this. It is this is x1, this is x2, this is x3, this is x4, this is x5. Now it is told in 4 complete oscillations. 4 complete. First oscillation is x1 by x2. The ratio between the first cycle is x1 by x2. Second is x2 by x3. Third is x3 by x4 and x4 by x5. There are 4 oscillations. That is equal to 1 by x1 by x5. You can write like this. If you cancel x2, x2, x3, x3, x5, you will get x1 by x5. So 5 oscillation means, because, and another thing is x1 by x2 is equal to x2 by x3, that is equal to x3 by x4, that is equal to x4 by x5. Always the ratio between the two consecutive amplitude are same. This also one condition we have. So now what is given? Amplitude to decrease to 1/10 of the initial value. 1/10 of the initial value in 4 oscillations. So that is x5 is equal to 1 by 10 of x1. That's the meaning. Amplitude decreases to 1/10 of the initial value. 1/10 of the initial value. So from this, we can take x1 by x5 is equal to 10, right? So this is equal to 10. So this can be written like this. That is x1 by x2, x2 by x3, all are same. So then x1 by x2, the whole power 4, that is equal to 10. Then what is x1 by x2? x1 by x2 is equal to 10 power 1 by 4. How much is this? This is 1.78. 1.78, right? Then the periodic force is 150 into cos 50t newtons. 50t newtons. So this one you have to compare with what? Already we have assumed forcing function or cos, whatever it may be, both are same. So how we have assumed the forcing function? We have taken f naught into sine omega t. Here we have 150 into cos 50t. So here omega is equal to 50, f naught is equal to 150. So that is what we can understand. So the force is 150 newtons, and at what frequency it is applied? It is 50. What frequency it is 50. So these are all the data given. So what you have to find? Find the amplitude of forcing function. Amplitude of forcing function. What is the equation for amplitude of forcing function? X is equal to f naught by k divided by root of 1 minus omega by omega n the whole square plus 2 into psi into omega by omega n the whole square. Here in this problem, f naught is, we have f naught. It is 150. We have the value of k. K is given. It is given here. Omega value, what is the value of omega? Omega is given. It is 50. It is 50. How to calculate omega n? We know omega n is equal to root of k by m. We have the value of k. We have the value of omega. So this is 31.6 radian per second. Omega n. We don't have the value of psi. That we have to calculate. We know log x1 by x2 is equal to delta. That is equal to 2 pi psi into root of 1 minus psi square. Minus psi square. Here what is delta? Delta is equal to, if you calculate logarithm of this, that is 10 power. So if you substitute here, this is log 10 power, this is 1.78. 1.78. Log 1.78, that is delta. That is equal to this value. So from this we can find the value of psi. The value of psi is equal to 0.095. 0.095. So this equation, we can calculate the value of psi. Now you substitute and find the value of x and find the value of x. So now what is f naught? F naught is equal to 150. 150 divided by k. K is equal to 10,000 divided by root of 1 minus omega is equal to 50. 50 divided by omega n is equal to 31.6. 31.6 the whole square plus 2 into psi. What is the value of psi? Psi is equal to 0.095 multiplied by omega is equal to 50 divided by 31.6 the whole power 2. How much is this? This is, you will get in meters, you convert it to millimeters, that is 9.8 millimeters. 9.8 millimeters. So this is the value of x, amplitude of vibration for omega is equal to 50. But now what it is given, what its value of resonance? What is the value of x at resonance? Resonance means what? Omega by omega n is equal to 1. Omega by omega n is equal to 1. So in this equation, substitute omega by omega n is equal to 1. So then XST, that is at resonance. At resonance. At resonance. Let us take the x max already, x max, that is equal to f naught by k divided by, this value will be 0. Omega by omega n is equal to 1. So 1 minus 1, 0. Here you will get 2 into psi. Because omega by omega n is equal to 1. We have square root. So 2 into psi. So now if by substituting this, you can get the value of x max, that is at resonance. At resonance. X resonance, otherwise you can take x resonance. That will be the maximum value. That's what I have taken, x max. That is equal to 150 divided by 10,000 divided by 2 into 0.095. The value will be 79.9. 79.9 millimeters. You will get in meters, you convert this. So when the body is vibrating it, when the forcing function is 50 hertz and the amplitude of vibration is 9.8 millimeters. If it is that omega by omega n value is equal to 1. Omega by omega n value is equal to 1. That means if the omega value is 31.6, then the amplitude of vibration will be this. Amplitude of vibration will be this, right? So that's what you can